Trigonometry is the study of triangles and the relationships between them and angles. So why is a circle so important? The unit circle isn't exactly so much a circle as it is a visualization of the relationships between trigonometric functions. What do I mean? To describe the unit circle, we're first going to need some background information. You may or may not be familiar with the term radians, but what exactly is a radian? Well, we know what degrees are, where triangles add up to 180 degrees and circles add up to 360. But degrees are a rather arbitrary form of angle measurement. Like, what defines a degree? Plainly, a degree is 1/360th of a circle's circumference. Now, that isn't very satisfying, since the vagueness of what a degree means doesn't allow it to be related to any other constants in mathematics. That's where the radian comes in. A rather beautiful relationship will show us important patterns later in geometry and other mathematics. Let's draw a circle with a radius of any length. It doesn't matter what the length is. Let's now mark out a section on the circle, called an arc length, that's equal to the radius of the circle. Now draw another radius length to connect the other end of the arc to form a sector. The angle between the radii is known as 1 radian. You can see how this makes sense in the name too. It has radius in the name. It's quite a neat relationship. Fun fact, this arc length up here is equivalent to the angle length down here at the center of the circle. They are both 1 radian. Great. We now know what a radian is, but now we're stuck, right? I mean, how are we supposed to convert between the two? There's a simple answer to that, but first let's explore some equivalency. A circle contains 360 degrees because 360 degree-sized arc segments can fit into a circle's circumference. A circle can also hold 2 pi radians, because pi radians, about 3.14159, fits into half a circle, and 2 halves make a whole. We know that much now. 360 degrees is 2 pi radians, and 180 degrees is pi radians. What now? Well, if we wanted to take 180 degrees and turn it into radians, we need some sort of operation. Since 180 degrees is equal to pi radians, we can simply multiply the fraction pi over 180, canceling out the 180 and leaving us with pi left. In fact, multiplying this fraction to any number of degrees will give us an equivalent number of radians. For example, 90 degrees multiplied by pi over 180 gives us pi over 2 when simplifying the fraction. 60 degrees gives us pi over 3, 45 degrees is pi over 4, and 30 degrees is pi over 6. Multiplying by the reciprocal, 180 over pi, can take a radian amount and revert it back to degrees. The easiest way to remember this is to take pi over 180 and realize that pi radians goes into 180 degrees. And the type of angle measurement you're trying to get to, in this case radians, is the number on top. That's great and all, but where's the unit circle? Calm down, calm down. I hear you, but we really need to make sure we understand a few things first, especially the trig functions and particular degree ratios. Remember how sine, cosine, and tangent are the ratios between the sides of a right triangle? Where given some angle theta on a right triangle, sine is the ratio between the opposite side and the hypotenuse, cosine is the ratio between the adjacent side and the hypotenuse, and tangent is the ratio between the opposite and adjacent sides, also known as the ratio between sine and cosine. Before this, you likely only dealt with ratios of numbers based on side lengths. But for this, we'll be focusing on 2 types of right triangles with specific angles. These are called special right triangles, primarily the 30-60-90 and the 45-45-90. These are particularly special triangles because of the relationship between their sides and angles. Let's start with the 45-45-90 right triangle. This triangle is special because it is the diagonal bisection of a square. and so the sides are the same no matter what the size of the hypotenuse is. With these triangles, we will be assuming the hypotenuse length is x, but in every situation we will be dealing with x, it will be equal to 1. This is known as the unit triangle. In a 45, 45, 90, given an angle theta here, which will be known to be 45 degrees or pi over 2 radians, sine will be equal to x radical 2 over 2, and cosine will also be x radical 2 over 2. This is true because if we were to instead say that the triangle had base lengths of 1, then the hypotenuse would have a different length of radical 2. Sine and cosine in this case are 1 over radical 2, which, if you rationalize the denominator by multiplying radical 2 on the top and bottom, is radical 2 over 2. Thus, sine and cosine of 45 degrees is radical 2 over 2. If you want to figure out what tangent of 45 degrees is, try dividing the result of sine over 45 degrees by cosine of 45 degrees, and see what your result is. Next up is the 30, 60, 90 right triangle. Here's what the relationship of this triangle looks like. It may look a little complicated, but it is really simple. The angle is 30 degrees, so now we take our trig ratios. Sine is x over 2x, which simplifies to simply 1 over 2. Cosine of the same angle is x radical 3 over 2x, which simplifies to radical 3 over 2. We can also reverse the angles, and we get the opposite results. Sine of 60 degrees is radical 3 over 2, and cosine of 60 degrees is a half. These relationships are incredibly important, and we'll see that soon. Let's look at a graph now, specifically the first quadrant. We will define this quadrant as an interval between 0 degrees and 90 degrees, represented by the notation in radians above, with pi over 2 being 90 degrees. Let's define a right triangle in this quadrant with the hypotenuse length 1, and some unknown angle theta here between x-axis and the hypotenuse. How about we say this is one of our special 30, 60, 90 right triangles, and that the angle theta is 30 degrees, which we'll write as pi over 6 radians. Now, let's quickly define sine and cosine. Sine of 30 degrees is a half, and cosine of 30 degrees is radical 3 over 2. Simple enough. Here's something interesting though. Because we are in the coordinate plane, we can find what this point here is at the top of the triangle. The x value of that coordinate is what cosine is, since cosine is representing the length away from the origin, while the y value is what sine is, since it represents how far up we are. This is not the only triangle this works for. All triangles have a point right here equal to cosine theta, comma sine theta. In essence, on a graph, cosine of a triangle is equal to x and sine is equal to y. However, be a little careful. This will only work for right triangles, and the hypotenuse of that right triangle must be equal to 1 for this to be true. Let's look at another quadrant where theta is greater than pi over 2, but less than pi. This is the second quadrant between 90 and 180 degrees. If we were to copy the triangle we had in the previous quadrant, not only would it be facing a different direction, but the bottom side is negative. Why? Why do we have a negative side? That doesn't make any sense. Well, simply, we're going in the negative direction on the x-axis. Remember, we are on a graph. You cannot have a negative side length, but on a graph you can. Does that mean cosine is negative here? In fact, yes. Tangent is also negative in this quadrant because tangent is equal to y over x. But sine is not negative because y is still going in the positive direction. Here are all 4 quadrants and what trig functions are negative in those quadrants. Remember the reciprocal functions too, which are just 1 over the main functions. Alright, it's time for the big reveal of the unit circle. You know most of it by this point, but we're going to tie everything together. Let's start by defining the unit circle. What is the unit circle? The unit circle is a circle with a center at the origin and a radius of 1. The points 1, 0, 0, 1, negative 1, 0, and 0, negative 1 are often marked on the circle since they are very important points. Remember how sine is y and cosine is x? When sine or cosine are at 0, 90, 180, or 270 degrees, they correspond on these points. Real quick, I'll show something briefly. Here are all the points where tangent, cotangent, secant, and cosecant are not defined. These are the only trig functions that are not defined at these points because you cannot divide by 0. Anyway, back to the circle. All points on the circle are coordinates, where sine and cosine are defined. A triangle here with an angle of pi over 4 radians, or 45 degrees, will have a sine-cosine coordinate of radical 2 over 2, radical 2 over 2. While a triangle here with an angle of 4 pi over 3 will have a coordinate of negative 1/2, negative radical 3 over 2. Here is a full image of a unit circle with full rotations in degrees and radians, as well as the corresponding points and values of tangent. This was only a brief introduction into the unit circle, and it can be used in much more complicated ways. Remember that it takes a lot of practice to memorize this important fundamental piece of trigonometry. Thank you for supporting me by watching this video.